langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Indah berbalam si awan petang, berarak di celah pepohon ara. Pemanis kalam, selamat datang, awal bismillah, pembuka bicara. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera dan selamat datang ke kelas tuisyen online percuma bagi subjek Fizik SPM yang dibawakan khas untuk anda oleh Akademi Youtuber Malaysia dengan kerjasama e-didik Malaysia dan Kelab Guru Malaysia. Apa khabar anak-anak pelajar, guru-guru yang dikasihi sekalian di mana jua anda berada? Saya doakan anda sentiasa berada dalam kesihatan yang baik. Okay, baiklah, Alhamdulillah pada malam ini sekali lagi kita bersama dengan saya Cikgu Hasnitah dalam tuisyen online percuma bagi subjek Fizik SPM yang dibawakan secara langsung untuk anda oleh Akademi Youtuber Malaysia dengan kerjasama Kelab Guru Malaysia dan e-didik Malaysia bermula percuma, selamanya percuma. Jadi kepada anak-anak pelajar yang mengikuti kelas pada malam ini, jangan lupa dapatkan link bahan PDF kopi yang cikgu pinkan pada slide message di sana. Anda boleh lihat nota ini boleh di-download secara percuma sahaja. Anda boleh cetak keluar dan jadikan dia sebagai bahan tambahan. Waalaikumsalam Rashid. Terima kasih kerana hadir. Harapnya dapat terus bersama kita pada malam ini. Untuk pengetahuan semua, cikgu akan kongsikan link e-sijil kelas pada malam ini di hujung siaran nanti. Pastikan anda isi dengan maklumat yang betul menggunakan sebarang domain email dan sijil akan di-emailkan ke email yang anda masukkan dalam borang berkenaan. Mudah-mudahan apa yang bakal cikgu kongsikan pada malam ini memberi manfaat kepada semua. Okey, baiklah, sebelum kita mulakan kelas pada malam ini, ayo kita mulakan dengan umul kitab Al-Fatihah dan doa belajar. Bagi yang bukan beragama Islam, anda bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. InsyaAllah mudah-mudahan kelas kita pada malam ini mendapat berkat oleh Allah Subhanahu Wa Taala. Okey, selain Benda Rashid, siapa yang ada menyaksikan kelas ini, anda boleh say hi di sana, siapa nama dan dari sekolah mana anda belajar. Okey, sekali lagi cikgu kongsikan link untuk slide PDF kopi. Anda boleh dapatkan pada pautan ini, juga disertakan pada description video kelas ini. Okey, jadi sebelum cikgu bermula, cikgu tunjukkan dahulu ini jadual kelas fizik kita pada minggu ini telah berlangsung Jumaat yang lepas. Kelas tingkatan 4 disampaikan oleh teacher SlindaNordin. Tajuk dia 2.6 daya. Jadi siapa yang tertinggal kelas ini jangan risau, anda boleh tonton semula ulangannya di channel teacher SlindaNordin dan juga dari channel Cikgu Rosemawati. So malam ini cikgu akan teruskan dengan tajuk 2.5 Archimedes Principle for DLP classes. Alright, okay. Dan cikgu perkenalkan dulu barisan guru-guru fizik yang ada di Akademi Youtuber yang telah banyak membantu menerbitkan video-video PDPC untuk fizik sama ada dalam bahasa Melayu ataupun bahasa Inggeris. Okay, walaupun ada di antara guru berkenaan tidak lagi bersama kita di Akademi Youtuber, namun jasa dan sumbangan mereka tetap kita kenang dan hargai. Okay, ini adalah apps Akademi Youtuber yang anda boleh muat turun di Android anda. Typekan saja dekat Google Play Akademi Youtuber. Apa yang ada di dalam adalah koleksi video-video PDPC bermula dari peringkat prasekolah hinggalah ke pra universiti. Dan setakat ini alhamdulillah kita ada lebih daripada 25,000 video PDPC untuk anda manfaatkan. Jadi muat turun apps ini hari ini dan anda bolehlah rujuk video-video PDPC yang ada di sana. Okay students, so without further ado, if you are ready and good to go, let us begin with our lesson tonight. So this is 2.5 Archimedes Principle. It is discussed in your textbook from page 66 until page 77. Alright? Okay. So first and foremost, this is the situation you can think about which is related to this topic's Archimedes principle. Okay, if you look at the GIF, okay, can you think how does such a heavy ship float? Whereas a block of steel, which is smaller inside, sink. Okay. So this is the question we can come up when we are learning about Archimedes principle. What do you think causes the heavy ship to be float, whereas a small steel of a block of steel sink? Right? In this video is to describe the relationship between buoyant force and the difference in liquid pressure at different depth for a submerged object. Kita nak lihat apa hubungan di antara daya apungan dan perbezaan tekanan cair pada kedalaman yang berbeza air. Alright, okay, that is the first learning standard. Okay, so student, if you look at this diagram, okay, it shows a bottle, an empty bottle is placed inside a container which is filled with water. And what you can see there, when we push the empty mineral bottle slowly into the water, kita tekan perlahan-lahan botol kosong tu, apa yang dapat anda perhatikan? Okay, you can write your response in the live chat there. Okay, so when we push an empty mineral bottle slowly, so you can see there is a water displaced from the container. Ada air yang disesarkan daripada bekas berkenaan. Okay, and pada masa yang sama, at the same time, when you push the bottle downwards, you will feel there is an opposite forces push your hand in the upward direction. Anda akan rasai ada satu daya yang menolak jari kita ke atas, ke arah yang berlawanan. So we say, yes, we will feel there is a force acting, okay, which in an upward direction. Okay, and in question B, when you push the bottle deeper, so what happened to the forces? So bila anda tolak lebih dalam botol ke dalam, so you will feel the forces acting on your fingers also increases. Okay, bila kita tolak lebih jauh ke dalam, kita akan dapat rasakan daya yang bertindak di ujung jari juga semakin bertambah. Alright? Okay, and also the volume of water displaced will be increases when we push deeper. Anda tolak lebih jauh ke dalam, lebih banyak isi padu air yang disesarkan. Okay, we also have Mr. Pei with us tonight. Thank you very much, Mr. Pei, for joining our lesson. Alright. Okay, students, so that is for the beginning. Okay, and then this is the next question related to the simple activity. Actually, you can try at home. Okay, so from here we understand the question here to state the relationship between buoyant force acting on the bottle and the volume of water displaced. So here we can say the greater the buoyant force, the greater the volume of water displaced. Okay, and what will happen to the bottle when you release your hand? You will see the bottle will accelerate upwards. Okay, it will accelerate in an upward direction. Okay, so that is for the first activities which can bring us to buoyancy or buoyant force. Okay, now let us take a look at the second diagram. Okay, this was taken from your textbook. Okay, we have a cylindrical object which is completely immersed in a water. So you can see obviously in this container. So this is the top surface of the cylinder. Down here is the bottom surface. H1 is the depth of the top surface of the cylinder from the surface of the water. And H2 is the depth of the bottom surface of the cylinder. Okay, so the first question, very simple. You have to compare the depth of the top surface, H1, and the bottom surface. Bandingkan saja kedalaman permukaan H1 dan H2. So we say H2 is greater than H1 or vice versa. H1 less than H2. Alright, okay. Selamat belajar semua. A wish from Mr. Pei. Alright, okay. And then B, now we talk about the pressure. Okay, pressure. We learned before in 2.1, when depth of liquid increases, the depth also, the pressure also increases. So that is the relationship between 2.1 and this topic here. All right. So let's say we label the pressure at the top surface as P1 and pressure at the bottom as P2. So if you compare P1 and P2, yes, so you can say P2 greater than P1. Pressure at the bottom surface of the cylinder is greater compared to the pressure at the top surface of the cylinder. So again, this is due to the depth of water. So we say here, the depth of water increases, the pressure also increases. So that is the relationship. Okay, students? Okay, next, what do we have? Okay, now they ask us to compare the force on the top surface, F1, and the force at the bottom surface. So the force here is related to the pressure acting. So we understand the force acting at the bottom is greater compared to the force acting on the top surface, where F2 greater than F1. Okay, and question B, what is the direction of resultant force acting on the cylinder? So since F2 is greater than F1, so the force acting from downwards. Okay, so the direction of the resultant force is upwards. All right, and name the resultant force produced. So we call this force as buoyant force. Okay, buoyant force, B-U-O-Y-A-N-T force, buoyant force. All right. Okay, so from these two examples, now we can come up with the definition. What is buoyant force, student? So buoyant force is defined as the force acting upwards on an object immersed in a liquid. Okay, when there is pressure difference between the lower surface and the upper surface of the object. So according to our previous example, buoyant force is the force acting in the upward direction. On who? On an object immersed in a liquid when there is a pressure difference between the lower surface and the upper surface of the object. Okay, so you can put a star here for the definition of buoyant force involving object which is submerged in a liquid. Right? Okay, next. So how do we come out or derive with the formula for buoyant force? So you can see the step in sequence. Okay, first, this is the diagram we refer in order to derive the formula for buoyant force. Okay, so first we have here a cylinder which is fully immersed in a liquid. Okay, so H1 is the depth of the upper surface, H2 is the depth of the lower surface, F1 is the force acting on the top surface, and F2 is the force acting on the bottom surface, where H is the difference, okay, in the difference of the depth of the lower surface and the upper surface. Okay, so the height of the cylinder, students, so this is the height of the cylinder labeled with H. So how do we find H? By subtracting H2 to H1. Okay, so we find H. This is the height of the cylinder. And then the volume of a cylinder, from a mathematical formula, we understand volume is area divided by multiply height. Okay, how to find volume of the cylinder? The area of the surface multiply with its height. So it gives you the volume of the cylinder, which is also equal to the volume of the water displaced by this cylinder. Okay, and the density of the liquid is given by rho density. Okay, well, the liquid pressure is rho GH. We learned this in 2.1. Liquid pressure is rho GH. Okay, so we write first, what is the pressure acting on the top surface? So on the top surface, P1, so it is rho GH1. Okay, and the force acting on the top surface, so this is force. Force is pressure multiply area. Okay, from the formula of P equal F divide A. So F1, pressure on top, equal to pressure on top multiply its area. And this one can be represented by rho GAH1. P, pressure here, can be represented by rho GH1. Okay. Okay, then the pressure on the bottom, P2. So P2 is rho GH2, pressure on bottom. Okay, while force acting at the bottom, okay, F2 equal to P2A, pressure at 2, which can be represented by rho GH2. Okay, and then A. So to find the resultant force acting on this cylinder, student, it is F2 minus F1. So what is F2? F2 is rho GAH2. F1 is rho GAH1. So we take out the same quantity and we put in bracket H2 minus H1. So it will give us rho GAH. Okay, here H is H2 minus H1. So finally, this is the formula for buoyant force where F equal rho GV. Okay, V is volume, which is AH. So this is the formula we derive from all the relationship of the height, the depth, density, pressure, and force acting on the top part and the bottom part of this cylinder. So again, the formula is F, buoyant force, equal to rho GV, where rho is the density, G is the gravitational acceleration, and V is the volume. All right. Okay, then how to apply this formula, we will check on the example in the next slide. All right. Okay. So this is the formula we derived in the previous slide. FB or F is rho GV. Okay. And students, okay, this buoyant force is also equal to the weight of liquid displaced. How? From this relation. Okay, where mass of the liquid displaced is M equal to rho V. Okay, while the weight of the liquid displaced W equal to mg. Okay, so here FB is rho Vg. So this rho V can be represented by M. So mg is W. So from here, FB also equal to W, which is buoyant force equal to the weight of liquid displaced. And this is what stated in Archimedes principle. Okay. So what is Archimedes principle? So it says that an object which is fully or partially immersed in a fluid will experience a buoyant force which is equal to the weight of fluid displaced. Fluid here can be either liquid or gas. All right. So I repeat, what is Archimedes principle? It states that an object which is partially or fully immersed in a fluid will experience a buoyant force which is equal to the weight of fluid displaced. All right. Okay. So you must know this very well in order to write the definition if the question asks you about buoyant force or Archimedes principle. Okay, again, for those who are just joining us, you can get the PDF slide copy for these notes, which is pinned in the live chat. And also, I have shared the link in the video description. Okay, you can download them just for free. Okay, so I hope it is beneficial and help you to follow this lesson. Okay, students, this is the sequence on how to determine the relationship between the weight of water displaced and buoyant force. This is according to our previous activity from step 1 until step 5. Okay, you can read them later on. All right. Okay. So this is the activity we conducted, okay, in order to find the relationship between the buoyant force and the weight of water displaced. So this is the water we place in a eureka can. So when we immerse this slotted weight, you will see there will be a water displaced from the eureka can. So when we collected and weighed the water using electronic balance, okay, so this is the data we obtain from this activity. Okay, so this is before the object is immersed. So this is what happened when the object is fully immersed in the eureka can. You can see this is the amount of water displaced from the eureka can. Okay, so First, we measure the weight of the slotted weight in air. It is 2.2 Newton. And when placed in a water, the weight reduced to 2.0 Newton. So there is a loss of weight of 0.2 Newton here. The loss of weight is actually the buoyant force acting on the block when it is fully immersed inside the water. Okay, while this is the mass of the empty beaker before the water is displaced, and this is the mass of the beaker plus the displaced water in the second diagram, 0.13. So there is an additional mass of 0.02 kg, where the weight of the water displaced is approximately 0.2 Newton, equal to the buoyant force acting on the object which is immersed in the water is equal to the weight of water displaced. Okay? Okay, students. So this is the discussion we can respond to according to this activity. Okay, so from the data analysis from the table on the previous slide, okay, the apparent loss in the weight, okay, is equal to the buoyant force. Okay. Second, the apparent loss in weight also equal to the weight of water displaced. Okay. And C, the weight of water displaced also equal to the buoyant force. So what is the conclusion we can come out? So we can understand the buoyant force acting on the slotted weight which is immersed in the water equal to the weight of water displaced. Okay, again, buoyant force equal to weight of water displaced. Okay. Okay, so how to conclude this part? So we have to understand here the weight of the object is the actual weight. Okay. And then when the object is submerged in liquid, you will find there will loss. Okay, the weight of the object in liquid is the apparent weight of the object. Okay, and the object displays a liquid, the volume of liquid displaced equal to the volume of the submerged part of the object in the liquid. Okay, and fourth, when the object experience apparent loss in weight, so we understand the apparent loss in weight is equal to the weight of the object in air minus with the weight of the object in the liquid, and the buoyant force acting on the object is equal to the weight of liquid displaced. Okay, so this is the conclusion we can make from the previous activities. Okay, I hope you are clear with this explanation. Okay, so now we can move to the second learning standard. Okay. So students, second learning standard, this is to relate the balance of forces with the state of flotation of an object in a fluid. So what enable an object to float in a fluid? We will see in this second learning standard. Okay, so first, this is the three situations to state the flotation of a body in a fluid. The first situation, when the buoyant force Fb equal to the weight. So what will happen to the object when the buoyant force acting on it equal to its weight? So the resultant force acting will be zero. Okay, the buoyant force is equal to the weight, so the forces is in equilibrium. So we understand resultant force is zero. So there is a balanced forces acting on the object. So what happened to the object? The object will be floating stationary. Okay, it will float stationary on the fluid. All right. Okay, so here, second situation. What happened if the buoyant force is less than its weight, which means the weight is greater than the buoyant force? So what will happen? We will have a resultant force which is acting downwards, okay, due to the bigger weight. So we say the object is now is in unbalanced forces, so it will accelerate downwards. Okay, it will accelerate downwards as you can see in this diagram. Okay, and the third case, what happened now if Fb, the buoyant force, greater than the weight of the object? So we understand there is a resultant force which is acting upwards due to the greater buoyant force. So here also the body is in unbalanced forces. So now it will accelerate upwards. Okay. So very simple. When FB equal to W, it will float stationary. When FB less than W, the object will accelerate downwards. And when FB greater than W, it will accelerate upwards. Okay, so the three states of flotation of a body in a fluid. All right. Okay, now students. Okay, what is the relationship between buoyant force, density, and volume of liquid or fluid displaced? Okay, so here you can see there is a ship. Okay, it can float on the vast sea or narrow canal if there is enough water to displace until the weight of the water displaced is equal to the weight of the ship. So what enable a ship to float at a different level when passing through a different sea or a different river? It is depend on the density of the river. Okay, for example, here, if you look at this diagram, now there are two forces acting on the ship. The first one is its weight, which is acting downwards. Second is the buoyant force, which is acting upwards. So these are the two forces acting on a ship, which is sail on a sea. All right. So here, what happened? The force acting on the ship are in equilibrium. Okay, as the ship is floating, so we understand the resultant force is zero. Okay, zero. So the weight of the ship at this situation equal to the buoyant force acting on it. Okay, and based on Archimedes principle, buoyant force equal to the weight of water displaced down here. Okay, so this is the amount of water displaced. It is equal to the buoyant force acting on the ship. Okay, where the weight of water displaced also equal to the weight of the ship. Okay, Cia Yao, thank you for supporting me. Cia Yao, terima kasih masuk kelas cikgu pada malam ini. Okay, and the volume of the seawater displaced, as I mentioned, this is the amount of volume of water displaced. It is equal to the volume of the section of the ship immersed in the sea water. All right. Okay. Okay, students. So that is the second learning standard. Later, we will see some exercises related to it. Okay. Now, for the third learning standard, how to communicate about the application of Archimedes principle in our daily life. Okay, let us go and see some example where to apply Archimedes principle in our daily life. Ya, setia dengan Ayu. Okay, terima kasih Cia Ya. Walaupun dah habis SPM, masih lagi setia dengan Ayu. Sekarang buat apa Cia Ya? Okay. Okay, now student, as for the first example, let us take a look at this floating ship. Okay, tengok kapal ni yang terapung ni. Okay, first, condition for a ship to float in the sea water. Apa syarat untuk kapal terapung di laut? Okay, what is the condition? So first, to displace an amount of water which has the same weight as its weight. So dia kena sesakan sejumlah air yang sama dengan berat dia. Okay, it has to displace an amount of water which has the same weight as the weight of the ship. And then only it able to float in a sea water. Okay, now B. This answer our earlier question at the beginning of this session. Okay, then. Okay, yeah. Explain why a boat made of steel will float in the water but a block of steel will sink. Okay, kita boleh invite lah Cia Yao ke dalam studio. Dah lama dia tak masuk studio kita. Right? Okay. So student, this is what happened to a steel boat. Okay, a gigantic size boat. it has a hollow space down there, which decreases its overall density. Okay, where a larger volume of water is displaced. Okay, and where the weight of the ship equal to the weight of water displaced equal to the buoyant force acting. So for a steel boat, since it displays a larger volume of water, so a larger buoyant force acting on the ship. So that's why it is able to float. Okay, whereas a small steel block, which is very high density, which is denser compared to a water, it only displays a small volume of water. So where the buoyant force is lower than the weight of the block, so that's why it sink. Okay, even though the size is much smaller compared to a steel boat, but since the buoyant force acting is very small because it displays very small volume of water, so it will sink compared to a steel boat. So that makes the difference between steel boat able to float because it displays larger volume of water, which is equal to its buoyant force. Alright? Okay, next. Okay, this is another example of how a fisherman find his boat is at different level when sailing in the sea and in the river, where the boat carry the same load. Okay, so this is the same boat with the same load, same fisherman in a sea water. Okay, and this is the fisherman with the same boat and the same load in a river water. You can see in a river water it sink more compared to when it is sailing in the sea. Okay, kita naikkan Cia Yao lah ke pentas. Hello Cia Yao, apa khabar?
Hai, kawan.
Sihat Okay. Thank you for joining us. So kita ada Syayau temankan cikgu di studio pada malam ini. Okay, kita tengok soalan yang pertama. Students, you have to compare the buoyant force acting on the boat. Okay, bandingkan daya apungan yang bertindak ke atas boat semasa di laut dan semasa di sungai. Okay, here you have to understand the boat carry the same load, which means it has the same weight. So, the buoyant force acting should be equal. So, answer is equal. Sama Okay. And then, compare the level of the boat. So, how we compare the level of the boat? So, you can say, the level of the boat in sea is higher. Or you can say, the boat sink deeper in the river. Okay. Then, compare the density of the sea water and river water. So, this is knowledge you have to have earlier before. We understand sea water has a higher density compared to river water. So we say density of sea water is greater compared to density of river water, or vice versa. Density of river water is less than density of sea water. Okay. And then what happened? Compare the volume of water displaced by the boat. So you understand in a river, when the boat sink deeper, which means it displays more volume of water. So we say volume of water displaced in a river is greater than that in the sea. Okay. And here the final question, how do we relate volume of water displaced and the density of the water to explain why the boat submerged deeper in the river? Okay. So actually, the buoyant force acting on both is equal. Okay, this is the first understanding you must have. Why the buoyant force acting is the same? Because the boat carry the same amount of load. So its weight is the same. So buoyant force acting is equal either in the sea or in the river. Okay. From this equation, second point, FB equal rho GV. So the buoyant force is constant. Density of C is greater. Okay. So that's why the volume of water displaced is less. okay, compared to the river. River has a lower density. So that's why it displays greater volume of water. Okay, and it is submerged deeper in the river. So I hope you can understand this. Okay, why there is a difference in the water level in the sea and in the river. It is due to the density of the sea and the river and also the volume of water displays. Right? Okay. Okay then. Okay, this is the further question from the boat. What if extra weight is put into the boat? Why will the boat sink further in the water? Okay, student. So when we add more load to the weapon, it will disperse more volume of water in order to maintain the buoyant force. So more water need to be displaced to keep the upthrust force. Upthrust force here mean the buoyant force equal to the weight of the boat so it still can float. Okay. So this is the reason why when we add more load, it will sink deeper in order to increase the buoyant force. So it will be equal to the weight of the loaded ship. Okay. Okay, second example, the plimsoll line. If you notice, there is a line which is drawn, okay, on the body of a ship. It is called as a plimsoll line. So what is the purpose of putting on this mark? This is to indicate the maximum depth for the ship to sail safely in a different density of water. Alright, so you can see this is the level of water. The same ship when it the level when it is sailed in a warm sea water, and the level will be higher. It is when it is sailed in a cold sea at different levels. So this is because the ship will sail at a different temperature, at a different density of sea water, which varies with location. Okay, so the purpose is to ensure the safety of the ship so it won't sink when it travel at a different density and different temperature as well. Okay, for example, let's say a ship, okay, at Klang Port. Klang Port is in Malaysia, in Selangor, is loaded until the lines is at T. So here, okay, loaded here. When it sails through Klang River, it will pass the line at TF. So when it sails through Pass River, the water level will happen. Why? This is because the density of the river water is lower compared to the density of sea water. So the ship displays greater volume deeper in Klang River. Okay. And now the same ship from Klang River now sail to England during winter, students. Okay. So the level of the ship in Thames River pass line W. So here in Thames River in England, this is the water level. It passed W. Okay, the question is why? So we understand during winter, a cold season, the density of the seawater is higher. Okay, so remember, higher density, less volume of water will be displaced, so it floats higher. Okay, so this is the reason. During winter, the density of the sea is higher, so at higher density, less volume of liquid will be displaced. So you can refer back to the boat in a river and in a sea water earlier. Okay, when density is higher, it displays less volume of water. When the density is lower, so it displays more volume of water and sink more. Alright? Okay, next. Okay, now the third application is a Cartesian diver. Okay, Cartesian diver. Actually, you can construct this Cartesian diver on your own at home. You just need a bottle filled with water and a test tube labeled with masking tape. Okay, so how to do this? There is a short video showing you how is the Cartesian diver works. Okay. So student, if you look, okay, we place this test tube invertedly into the Cartesian diver, so you'll see it will float. There is a trapped air on the upper part of the inverted test tube. So when you press the bottle, so what will happen? You will see the Cartesian diver will sink. Okay, and when you release the bottle, you will see the Cartesian diver will float back to the surface. So when we press, actually we apply force to the bottle. So we apply force, so pressure will be increases. So that's why it sink. Okay, and we release the force, the pressure also decreases. So that's why it is floating upwards. Okay, so here. Okay, then. Okay, this is a video shows to you how Cartesian diver works. Okay, so when the test tube is floating, total weight of the tube plus the weight of the water equal to the buoyant force. Okay, pressure exerted on the wall causes the water to be pushed into the test tube, so the weight will be greater, so it will sink. Okay, then when the bottle is released, so the pressure will be reduced and it displays more water from the Cartesian diver, so it will float. Okay, as the buoyant force is greater than the weight. Okay, so that is caused the difference in the floating and sinking of the Cartesian diver in a bottle. All right. Okay, now the fourth application is a submarine. Submarine. Okay, if you look at the submarine, how it able to submerge and float, that is due to a very important structure called as the ballast tank. Okay, ballast tank. So what is the function of this ballast tank? It is to control the position and the depth of submarine in water by controlling the quantity of water inside. Okay, students. So what happened when the submarine, the ballast tank is filled with water, the weight will be greater than its buoyant force, so it will sink. Okay, and in order to rise up, the water will remove from the ballast tank, where at that moment the weight is less than the buoyant force, so the submarine rises. Okay, simple ballast tank. And last but not least, we have a hydrometer. What is hydrometer? It is an apparatus which is used to measure density of a liquid. This is how a hydrometer looks like. Okay, so if you look down here, there is a lead shot placed in the glass tube. So what is the function of this lead shot? It is to stable the hydrometer when we place it in a liquid, so it will float vertically upward. Okay, the function is to stabilize the hydrometer. And why does the size of the air-filled glass bath is larger down here? Why? So this is to create greater buoyant force. And if you look the hydrometer, it has a long and thin stem. Okay, so this is to ensure it is more sensitive, which means can detect small changes, and also to measure wide range of density. It has to be longer so it can measure wide range of density, and the stem is thin so it will be more sensitive, can detect small changes. Okay, so this will increase the sensitivity and accuracy of measuring density. All right. Okay. So let's go with the application, 5 applications of Archimedes principle in our daily life. And now students, let us take a look at one exercises, how to use hydrometer to determine various density of liquid. Okay, we have 2 liquid here, liquid A and liquid B. Okay, you can see in liquid A, the hydrometer floats higher. Okay, in liquid B, it float lower, or it more immerse in liquid B. Okay, then so we understand from here there is a difference in density between liquid A and liquid B. And this is sum of the density of a distilled water, alcohol, and sea water. Distilled water with 1 gram per centimeter cube, alcohol 0.8 gram per centimeter cube, and sea water 1.02 gram per centimeter cube. Okay. So as I mentioned, we can use this hydrometer to measure density of a different liquid. All right. Okay. Okay, this one. Okay, what do you say about density of liquid A and liquid B? Which one do you think is denser? Liquid A or liquid B? So if you look here, buoyant force in liquid A equal to the buoyant force in liquid B because hydrometer has an equal weight. Okay, so for a floating object, buoyant force equal to its weight. Okay, second question. What will happen to the hydrometer when it is placed in a liquid of lower density? So then remember, when the density is lower, so the object, which is the hydrometer, it has to displace more volume of water. So it will sink more. So here we understand liquid B has a lower density compared to liquid A. All right? Okay. Very good. And the last application, I think we can check on a hot air balloon. Okay. Again, this is the two force acting on the hot air balloon. The first one is its weight acting downwards, and the second force is the buoyant force acting upwards. Okay, so these are the two forces acting, weight and buoyant force. Okay, now you can compare density of air inside the balloon and outside. So the density of air in the balloon is lower compared to the density of air outside. Okay, give two methods can be done so that the air inside the balloon can rises. Okay, so first we heat the air inside the balloon. Okay, so when by heating the air, we decrease the temperature, we decrease the density of the air inside. Okay. Second, we can increase the size of the balloon. So when the size of the balloon bigger, which means it can displace more air. So when it displaces more air, the buoyant force also increases. So it will float more or rises in a higher altitude. All right. Okay. Next. Okay, this is also to relate with the size of the balloon. So why the size has to be big? So to displace more volume of air, so the buoyant force increases, it can float higher. Okay. Compare the buoyant force and the weight of air displaced. Remember, buoyant force equal to the weight of a displaced. Okay. And six, what happened to the balloon if buoyant force greater than its weight? So you understand the balloon will rises. And when the buoyant force equal to the total weight, so it will float stationary. Simple, right? Okay. Next to the exercises part, what if we take a short break first? Okay, jangan ke mana-mana, kita akan kembali seketika. Okay, students, welcome back to our lesson, Fizik SPM, a free online tuition brought to you by Akademi Youtuber Malaysia with the collaboration of EDD Malaysia and Kelab Guru Malaysia. Bermula percuma, selamanya percuma. Okay, for those who are just joining us, don't forget to get your slide PDF copy for this lesson. You can download and print them all for free. Okay, where is the link? It is pinned in the live chat, and also you can get them from the video description in this video, in this lesson. Okay. So let us continue with the fourth learning standard to solve problem involving Archimedes principle and buoyancy. Okay. So from the beginning of the lesson, you have understand buoyant force acting on an object which is immersed in a fluid equal to the weight of the object and also equal to the weight of the fluid displaced. All right. And when we have the same object, which is float in a different sea with a different density, you will find the object will sink deeper in a liquid which have a small or low density, where it has to displace more volume of water in order to maintain the buoyancy or to maintain the weight of the object. All right. Okay. So now let us take a look at a few example of question relate to these topics. Okay. First, okay, we go to the simple question first. Okay, you are having this figure. We have an object hang in the air. The actual weight is 65 Newton. Okay, and once the object is fully immersed in a liquid, the weight decreases to 30 Newton. So this is what we call as the apparent weight. 65 is the actual weight. 30 Newton is the apparent weight. So what is the buoyant force acting? Remember, buoyant force is the lost in weight. So what is the lost in weight? 65 minus 30 is 35 Newton. Okay, and this is equal to the weight of water displaced, which is 35 Newton. Okay, now how to find the volume of the water displaced? You can see when we immerse this block, the water level rises, which means it displays some amount of water. And we can find the volume by applying this equation of FB, buoyant force, equal to rho Vg. So FB is 35. The density is given 1000 kilogram per meter cube. We are looking for V. Gravitational acceleration is 9.81. So by this, the volume of water displaced is 3.568 times 10 negative 3 the cube. Alright? Okay, next. What is the volume of the object, students? Since the object is now fully immersed. So 100% of the body is inside the water. So we understand the volume of the object immersed equal to the volume of water displaced, where 3.568 times 10 negative 3 cubic meter. Alright? Okay. Okay, then second question. Now we have a stone with its weight 2.5 Newton. When the stone is fully submerged, so you can highlight the fully submerged in the fluid, its apparent weight is 2.2 Newton. So actual weight is 2.5. Okay. Underwater, it is 2.2 Newton, which means the buoyant force is, yes, very good. The buoyant force is 0.3 Newton. Okay. So they ask you to find the density of liquid when the volume of liquid displaced by the stone is 25 centimeter cube, or in cubic meter is 25 times 10 negative 6. Alright? Okay. So this is the formula. Buoyant force equal to weight of object in air minus the weight of object in water, which is also equal to rho Vg. So the buoyant force 0.3, density of liquid, okay, we are looking for. And this is the volume. Okay, the volume of liquid displaced, it is given. This is gravity. Okay, so answer, density of the liquid is 1223.24 kilogram per cubic meter. Alright? Okay, next question. Okay, question 3. We have 8 questions altogether. Hope we can finish by before 10. Okay, now we have a glass tube with this mass 0.012 kg with a uniform diameter. See, uniform diameter and a cross-sectional area of 4 times 10 negative 4 meter squared. So that is the dimension of the glass tube. Okay, here, the glass tube is here. Okay, then it is filled with lead shot. Down here, there is a lead shot. So it's made the vertical in a beaker, so it can stabilize vertically when placed in this glass of water. Okay, so students, first you are asked to find the volume of water displaced. So what is the amount of water displaced by this glass tube? So volume is AH, area multiply height. So this is the area of the glass tube. It is given. Okay. And this is its height in a unit of meter. So the volume of water displaced is equal to the volume of glass tube under water, which is 3.2 times 10 negative 5 cubic meter. Okay, simple. And then B, how to find the weight of water displaced by the glass tube. So weight of water displaced equal to the buoyant force, rho Vg. So the density is 1000 given density of water. So this is the volume we calculated earlier, volume of water displaced, and this is gravity. So it is 0.314 Newton, the weight of water displaced, which is also equal to the buoyant force or acting on the glass tube. So B and C has the same answer, 0.314 Newton. And then finally, find the mass of the lead shot inside the glass tube. Okay, how to find the mass? So you have to understand buoyant force is equal to the total weight of the glass tube. Total weight means the weight of the tube itself plus the weight of the lead contained in it. Okay. So this is the buoyant force we calculated earlier in B and C. So this is the weight of the glass tube, mass multiply gravity, and this is the weight of the lead we are looking for. Okay, so the weight is 0.19628 Newton. So how to find the mass? You just divide this with 9.81. So the mass of the lead shot will be 0.02 kilogram. Simple, right? It looks complicated, but actually it is simple. Okay, next, question 4. And now we have a fisherman. When the fish is still inside the water, okay, he will very easy to pull it upwards. But once the fish is outside of the water, the fisherman find difficulties in order to carry the fish. So what caused this? For students, when the fish is inside the water, the weight of the fish is lower. Why? Because there is buoyant force acting on it, okay, when the fish is still in water. But once it come up from the water, so the weight of the fish in the air is greater, which is the actual weight. That's why the fishing rod bend more to balance the greater weight of the fish. Okay, so this is the reason. In water, there is a buoyant force supporting its weight. So the weight in water will be reduced. But once it come out to the air, there's no more buoyant force acting, only its weight. So which is greater. So more forces is required to support the fish. Okay, next. Number 5, we go to hot air balloon. It has a volume of 2080 cubic meter. Okay, contains hot air balloon of this mass, 1900 kg. Okay, then the question asks you, what is the weight of the extra load that can be carried so the balloon will float stationary in the air of density 1.3 kilogram per cubic meter. So this is K-BAT question. So we understand, student, the weight of air displaced by the hot air balloon equal to the total weight of the hot air balloon, mean the weight of the balloon plus the load it carries. Okay, so this is weight of water displaced equal to buoyant force, rho Vg. So this is the weight of the balloon, mg, plus weight of the load. Okay, so this is the density of the air, 1.3. This is the volume of air, the volume of the hot air balloon, and this is gravity. This is the mass of the balloon, 1900 kg multiplied by gravity. So now we can find the weight of the extra load it can support, where it is 7,887.24 Newton. All right. Okay. Next, question 6. Okay, this is an example of a structure question. Okay, we have a log which is now floating at the surface of a river water. So, as it is floating, so you have to understand there are two forces acting on this log now. The first is the weight acting downwards. Second is the buoyant force acting upwards. Okay, first question, name one force acting on the log. So you can put any one. Either you say the buoyant force or the weight of the log. Alright? Okay, second, give one reason why the log floats. Simple, student, why it floats? Yes, because the buoyant force equal to its weight. The buoyant force acting on the log equal to its weight. Alright? Okay, next. Okay, now they give you this information. The log has a mass of 1,200 kg and density of the river water is 1,000 kilogram per cubic meter. So you have to calculate the volume of water displaced by the log. Okay, find the volume of water displaced by the log. Okay, so here is the formula we are applying. Remember, buoyant force acting on the log is equal to its weight as it is now floating. So buoyant force is rho GV equal to its weight mg. Okay, so this is the density of the river water, 1,000. Volume of water displaced we are looking for. This is gravity, 9.81. Mass of log, 1,200 multiply gravity. So by this, the volume of water displaced is 1.2 cubic meter. Alright? And this is also equal to the volume of the log, which is under the river water, 1.2 cubic meter. Okay, next question. What happened to the volume of water displaced when the log floats in sea water? Remember, student, sea water has a higher density compared to river water. So in sea water with a higher density, it will displace less volume of water, so it will float higher in a sea water. So answer, what happened to the volume of water displaced? It will be decreases. Alright? Okay, next. We have question 7 involving a submarine there. It is now floating stationary on the surface of the sea. Okay, so state the principle enable the submarine to float. So what is the principle applied here? So it is Archimedes principle. Okay, Archimedes principle. Okay, then they give you the mass of the submarine, the density of the sea water. So you have to find the buoyant force acting on the submarine. So first, buoyant force acting on the submarine equal to its weight. Simple. Okay, so the mass here given density, this is gravity. So it is 1.54 times 10 power of 8 Newton. Okay. And second, find the volume of the sea water displaced. Remember, buoyant force is equal to the weight of water displaced. Okay. So we can find the volume of water displaced here. So this is the buoyant force calculated earlier, density of the sea water. So this is the volume and gravity. So by this, volume of sea water displaced 1.524 times 10 power of 4 cubic meter. Alright, simple, right? Okay, now, last question for number 7. Okay, when the water is filled into ballast tank, okay, so the submarine submerged into the sea. Give one reason why it submerged. Remember, when we add water into the ballast tank, what happened to the weight? Very good. The weight increases. So now the weight is greater than the buoyant force, and that's why it sinks. Okay, so the answer, because weight greater than the buoyant force. Alright? Okay, so I guess we have come to the final question for tonight. Take a look at one example of question in section C involving a theory to be answered. Okay, first you are given 9.1 and diagram 9.2. It shows a hot air balloon floating stationary in the air during afternoon. Okay, 9.1 during afternoon. 9.2 is the position of the same hot air balloon floating stationary early in the morning. So you can see early in the morning, it float higher. Okay. At afternoon, this is the position of the hot air balloon. It is closer to the ground surface. So the first question, what is meant by density, student? Remember, density? Density is mass per unit volume. Remember the formula for density? Density is mass divide volume. So how we write this in words? It is mass per unit volume. Okay, density. Okay, next question, B. You have to observe both diagram and compare these few things. First, compare the height of the balloon. So you can see the height of the balloon in 9.2 is greater than in 9.1. Okay, second, compare the density of the air and the temperature of the air outside the balloon. So we say density of air outside the balloon in 9.2 is greater than in 9.1. Temperature of air outside the balloon in 9.2 greater than in lower, sorry. Temperature of air outside the balloon in 9.2 lower than in 9.1. Since 9.2 early in the morning, so the temperature is lower compared to 9.1. Then fourth, compare. Okay, the height we have to relate the temperature, the density, and the buoyant force and the temperature. So we understand the higher the temperature of air, the lower the density of air. Here, higher temperature, so density of air outside is lower. Then the higher the temperature of air, the lower the buoyant force. Okay, higher temperature, lower buoyant force, so it floats at lower height. Okay. Okay, then student in question B, there is a student, there is a boy holding a balloon which is filled with gas. The question is, explain why the balloon rise up when the boy released them. So now he's holding the balloon. Once he release it to the balloon rise up. So what caused that? First, we can say the density of the gas inside the balloon is lower than the air outside. Okay, first point. Then the weight of the balloon is low. Okay, buoyant force equal to the weight of air displaced, and in this case, the buoyant force acting on the balloon is greater than its weight. So that's why it is floating when the boy released them. Alright? Okay, final question is the 10 marks essay question. We are having a hydrometer here, okay, which is used to measure density of a liquid. So you're asked to do some modification on the design so that it become more sensitive and able to measure a wide range of density. Okay, before that, I think I can share to you the link for the e-sigil for tonight. So while we are discussing the final question, you can start to fill up your e-cert. Alright? Okay, so your discussion must be based on the following aspect. First, the length of the stem. So the length must be longer or shorter. Okay, material used for the hydrometer must use plastic, glass, or what material. Diameter of the stem need to be bigger or need to be smaller. Size of the glass bulb down here have to be bigger or have to be smaller. And number of lead shot need to be more or need to be less. Simple, student. Okay, so we prepare a table of modification or suggestion with reason. So first, the length of stem, it has to be longer. Why? So to place small scale division, or you can say it can measure wide range of density. Okay, to measure wide range of density. Second, material used for the hydrometer, so we can use plastic or glass. Why? Because number one, they do not corrode or do not rust. Second, they are transparent. Okay, glass and plastic are transparent, so easy for us to read the density. Yes. Okay, then what about the diameter of stem? Remember, the diameter need to be smaller. Why? So it will be more sensitive, higher sensitivity, or able to detect small changes in measurement. Okay. And what about the size of the glass bulb down there? It has to be bigger. So why? To create greater buoyant force. Okay. And finally, the number of leg shot, it need to be more. Why? So this is to give stability to the hydrometer so it can float vertically upright when placed in a liquid. Okay, so this is all the suggestion we can give together with the reason on modifications on the hydrometer. So again, this is the link for the insert for our class tonight. You can fill up by using any email domain, and please fill up with a correct information. So we can send the link through your email in 3 working days. Okay, so I guess students, that's all for tonight. We have discussed 2.5 Archimedes principle together with others. So I hope this class benefits and give you a better understanding on 2.5 Archimedes principle. Alhamdulillah, kita dah berjaya habiskan kelas pada malam ini. Terima kasih cikgu ucapkan kepada Syayau yang tadi temankan cikgu di studio. And thank you very much for those who are still with us. I hope our class tonight will be beneficial to those who are watching. Terima kasih kerana sokongan anda yang berterusan kepada Akademi Youtuber. Doakan kami guru-guru fizik di Akademi Youtuber terus kuat dan bersemangat untuk meneruskan kelas-kelas tuisyen percuma ini di masa yang akan datang. So jangan lupa bersama-sama dengan kami pada minggu hadapan. Kita akan ada kelas yang berikutnya akan disampaikan oleh teacher SlindaNordin untuk tajuk yang pertama untuk bab 3, gravity. Dan pada hari Ahad 8.45 malam akan disampaikan oleh Mr. Pekok Hua untuk tajuk yang seterusnya 2.6 Pascal Principle, the last topic on chapter 2. So sekali lagi terima kasih kerana terus menyokong kami di Akademi Youtuber. Semoga kelas-kelas yang kami bawakan memberi manfaat kepada semua yang mengikuti kelas ini. So jangan lupa isikan link sijil. Dan insya-Allah kita jumpa lagi dalam siaran yang akan datang. Sekian dulu. Assalamualaikum dan jumpa lagi.
Semua para ilmuwan, semai ilmu kepada anak wawasan, tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rakan laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa.
Akademi Youtuber Malaysia, berpadu bersatu keluarga AYU, memberi ilmu tanpa jamu, siap sedia menyumbang ilmu.
Ilmu diberi juga dikongsi pada semua generasi yang terkini. Lahir generasi yang berkualiti, sedia berkhidmat pada pertiwi. Akademi Youtuber Malaysia, rakan laksana dengan jitu, penuh bermisi guru AYU, mencapai misi yang satu. Permisi kita, bantu kita, bermoto sendiri yang kita biasa, bersama kita luar biasa, berjasa demi nusa bangsa. www.academyyoutuber.com Berusaha ayu, capai kecemerlangan. Berpadu ayu, cipta kegemilangan. Bersatu ayu, bina wadah terbilang. Terus berjaya bersama ayu.
Berusaha ayu, capai kecemerlangan. Berpadu ayu, cipta kegemilangan. Bersatu ayu, bina wadah terbilang. Terus berjaya bersama ayu.
Mara semua para ilmuwan, semai ilmu kepada anak wawasan. Tak kira di utara selatan, sampaikan ilmu penuh kesungguhan. Akademi Youtuber Malaysia, rangka laksana dengan jitu. Penuh bervisi guru ayu, mencapai misi yang satu. Bervisi kita, bantu kita, bermoto sendiri yang kita biasa. Bersama kita luar biasa, berjasa demi nusa.